that. We need this calendar. Okay. Advent of Code 2025 Day 2 is called Gift Shop. You get inside and take the elevator to its only other stop, the gift shop. Thank you for visiting the North Pole, gleefully exclaims a nearby sign. You aren't sure who's even allowed to visit the North Pole, but you know you can access the lobby through here, and from there, you can access the rest of the North Pole base. Good. Oh yeah, I wanted to say that it looked like this is the top of the, this is like snow, right? And this I think represents the North Pole, and maybe this is the snowman we made with a carrot nose. As you make your way through the surprisingly extensive selection, one of the clerks recognizes you and asks for your help. As it turns out, one of the younger elves was playing on a gift shop computer and managed to add a whole bunch of invalid product IDs to their gift shop database. Surely it would be no trouble for you to identify the invalid product IDs for them, right? They've even checked most of the product ID ranges already. They only have a few product ID ranges, your puzzle input, that you'll need to check. For example, okay, the ID ranges are wrapped here for legibility, and your input, they appear on a single long line. The ranges are separated by commas. Each range gives a first ID and last ID separated by a dash. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made only of some sequence of digits repeated twice. So 5 twice, 6 4 twice, 1 2 3 1 2 3 1 2 3 twice would all be invalid IDs. Okay. If I'm being pedantic, it's repeated once. Right? This 5, and then the 5 gets repeated one time. So, but I'm not going to get pedantic. So ignore what I just said. None of the numbers have leading zeros. 0101 isn't an ID at all. 101 is a valid ID that you would ignore. Your job is to find all the invalid IDs that appear in the given ranges. Oh, okay. See, I'm misreading this. I thought it was like we're looking for double digits or this, but it's if the number itself is just two copies of the same pattern. It's not like 1 2 3 1 2 3 is inside another number. Okay, so it makes it relatively simple. Well, we need to split the number in half and then compare the upper half and lower half, right? And right, 999 is in this range, but doesn't count because it's okay, it's 3 digits, which means we only have to care about the numbers that are even numbers of digits, right? And then we can split it in half and then see if the upper half matches the lower half. Okay, all right. Let's see, get input 2025 day 2. Let's see if my script works. If not, I'll have to do it by hand. Oh, there we go. One line of input. I have my code wrapping it, so that's why it looks like multiple lines. So this is actually 123001. Okay. The ranges look pretty big. I was going to say, well, we'd have to loop. We probably could figure out a clever way to find duplicates, because we only care about the like here, if it's 8, we only care about 4 digits worth of duplication. So we could just come up with those 4, although we do have bigger ranges. All right. Enough faffing about. Let's say ranges are going to be a vec of range. Now, Rust has its own range type. So let's not use that. Let's create our own. And they're just called ranges. So if we just say range, that's fine. We're not going to use that type in here. We'll grab this. We'll change this to ranges. And then we can say impl from stir. Actually, it's not lines, parse lines. Right? We want... Oh, I can't go there without the use statement. wanted to jump to it really quickly. It's doing a line at a time. So let's just do it differently. We're going to say lines of 0 because it's just a single line of input. And instead of parse lines, we're going to say split on comma. Then we're going to say map range parse unwrap collect. And I have a syntax error because I forgot to do this. Okay, that should work if we impl from stir. Impl from stir for stir. I think these are stirs. What are these? They are stirs. Okay. Oh, no. From stir for range. And we need a range type now. So struct range start is going to be, I guess they're all U sizes. I didn't see any negative numbers in there. Simple that. Error is this. So we're going to say let left right is equal to s split once on a minus sign unwrap. And then we'll say, okay, range start is left parse unwrap and end is right parse unwrap. All right, if we do this, we should be able to print out all the ranges. Self ranges. All right, and that's probably correct. 616 something, and it goes all the way to this one, 988344. Okay. So the next thing I want to do is find out how many numbers we're talking about. Because if this is in the billions, then we're going to have to be super clever. But if it's small, like a couple hundred, then we should be able to just brute force it. What we can do is say self ranges iter map range start minus range end plus 1 because it's inclusive, and then some U size. All right, let's see what that is. That is a failure. Oh, we don't need this line parser. Oops. Attempt to extract with, it's end minus start. Oops. I should have just done abs diff or something. Okay. Oh, it's only 1,000,000, 1.5 million. Okay, we can definitely do this brute force. So we can say for range in self ranges. We only care about it if it has an even number of digits. So we'll say for num in start ... equals end. Oops. Range start. A range end. So what we need to do is check the number of digits in the number. And I believe, let's take a quick look at Rust. They have POW. Yeah, usize POW. Oh, that's POW. No, I want log. Is there a log base 10 or is there only a log base 2 or something? I don't see it in. Oh, I see. I see it here. ilog. It's called ilog for integer log. For an arbitrary base. Oh, there is log 10. Okay. Oops. There it is. Log 10. Okay, perfect. So let digits is equal to, and it's rounded down. So we're going to have to add 1. Num log, ilog 10 plus 1. And now we can get the lower, so half, we only care about half digits, half the digits, right? So it's going to be this divided by 2. Maybe I'll only do the first range because I want to print out a bunch of Let's do this self ranges 0 start self. Let's get rid of that, and we don't need this anymore. So let's say println num has digits half digits times 2. I think that's going to be right. No, it's a lot of output. Oops, I probably should have picked a small range. 3, 6, 9, 10. Yes, so we're calculating the number of digits correctly. So what we need to do now is generate the value to mod it by, right? Because we're going to mod to get the lower half, and then we'll divide to get the upper half. Okay, so we can say let lower half is equal to, actually let mod, can't use mod, but I can say mod val is equal to half digits pow. No, 10 to the power of half digits. 10 pow half digits. And then we can say lower half is equal to, and I'm going to actually quit out of bacon so I can run this without waiting for 20 minutes. Num mod val, and let upper half is equal to num divided by mod val. And then we can say println num splits into lower half and upper half. And we can find out where they're equal, right? Cargo run less. Oh, you must specify a concrete type for this numeric something. What does that mean? Oh, I have to tell it what type it is. Okay. That's what it means by concrete type. So we're using usizes. We might as well use usize here. Happy affiliate anniversary. Oh, that's what Busy Kim was talking about. Yeah. Was it today that I started? Okay. Very cool. All right. So we have the lower half and the upper half, 88, 270. So let's see if we can find 61, 615, and we can. Okay. Oh, and 61616. Oops. Oh, here. So this is the pair. So let's see if we can find pairs. I didn't realize Twitch was broadcasting that info. Okay, so here's what we're going to do is we're going to implement this on range because it's really about the range. So fn find pairs invalid IDs, right, of self, and we'll return a vec of, what do we actually calculate? I lost the thread of this conversation here. What do you get if you add up all the invalid IDs? Okay, we can do that. So we'll just say vec of invalid invalid IDs. So we can just say here, we can grab this, put this here, self start to self end, and just generate a. Now, the reason I have to do this inside the loop, unfortunately, is that it could change, right? For example, here we go from 2 digits to 3 digits. So I can't grab it from the first one and then do it. So I think it's going to be fast enough. So I'm not too worried about it. But what we should probably do is we should do this in a more rusty way. Self start dot equals self end dot map num open brace. And then instead of this, we say close brace and say collect. Right? I think that'll do the trick. Oh, you have to filter map if lower half equals upper half, then we'll say sum num, else none. Does that compile? Yes, it does. Okay, so for part 1, we should be able to just add them all up. Self, ranges, map, range, flat map, range, find invalid IDs, and then sum usize. Oh, iter. Okay. All right. And if I run that, we get this big number. Hey, that's the right answer. All right. Okay. Div seal instead of doing this. Very good. Okay. Let's try it. Right. If we do this, do we come up with the same answer? Let's see. What was the answer before? This number? It's still saying filter map can be written more simply as filter. Oh, okay. That's true. Then what we can do is just filter this and then just sum. No, collect, right? Because we're just collecting the numbers that, okay. And if I hit run, is it the same number? It is. Look at that. Okay. Clippy is great. I love Clippy. Everybody should have a Clippy. Is there anything we can do to simplify this? This seems pretty simple to me. We get all the ranges, we iterate over them, we map, we generate a vector of all the invalid IDs in each range, we flatten it using flat map, and then we add them all up. And here we just loop over every number, split the number in two, and then filter out all the ones that don't have equality, and we collect that into a vec. I could just sum them up here. Would that be easier? I think that might be easier. Let's see if it'll generate the same. It should generate the same value, right? Sum. And that way we don't have to do a flat map here. In fact, I might be able to get away with map find invalid IDs. Range, colon, and run. And that's the same answer. Okay. So it's even simpler. So this should be sum invalid IDs. There. I was hoping this would go on a single line. If I make it really small, sum. Yeah, look at that. How long does it have to be before it breaks? Invalid. Oh, good. Okay. So let's use that one because that gets it onto a single line. Clippy, still good. Git commit dash, git status. Git add dot, git status, git commit dash m. AOC 2025, day 2, part 1. All right, let's see what part 2 is. Continue to part 2. The clerk quickly discovers there are still invalid IDs in the ranges in your list. Maybe the young elf was doing other silly patterns as well. Now an ID is invalid if it is made only out of, inserted the word out, is made only of some sequence of digits repeated at least twice. So 1, 2, 3, 4, 1, 2, 3, 4 is 1, 2, 3, 4 two times. 1, 2, 3, 1, 2, 3, 1, 2, 3 is 1, 2, 3, 3 times. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2 is 12, 5 times. All right, so this is a little more complicated. What we could do is mod one at a time, right? We take the bottom number, mod it, and then check all the remaining digits and see if they are equal to that. And if not, then what we'll do is we mod the lower two numbers off. So 85, and we check to see if this is 85 and this is 85. And if they all are, then we're good. Otherwise, we take the bottom three numbers and we keep going like that until we run out of numbers, or until we get halfway up. Once we get halfway up, we know there can't be any more repeats. So I think this is going to call for a test. So let's write a test. What should we call it? Test multiple IDs, multiple invalids. Sure. So if we take this range, we should be able to find that invalid one. That one's too easy. Let's do one that's harder. This one looks like it's harder. This has one invalid ID, 824, 824, 824. Okay, so let's create a range. And then we're going to insert that it's equal to 824, 824, 824. And we're going to say range get sum all invalid. Sum multi invalid. That's what we'll call it. Yep, I know there's a sum invalid. Thanks, Rust. I'm going to write a sum multi-invalid. Fn sum multi-invalid self use size. Let's just return 0 for now so that we can see that the test fails. Good. And this is what's going to be up here. So we'll just grab that, change that to this, change this to multi, and now it's going to go on several lines. Yeah, I'm sad. I'm very sad. But we can live with that. All right, so we're good. So what we need to do now is figure this out. So we're going to take the starting value. We're going to go through each number. I'm just going to write it iteratively. And then if we can convert it into this thing kind of deal where we have a little bit of functional style, then we'll do that. For num in self start, self end, let mod invalid sum is equal to 0, and then invalid sum. So how are we going to do this? We're going to get one digit at a time until we get halfway there. So we're going to grab the half digits, and we're going to say while for digit count in 0 dot dot half digits. What I probably should do is before I do this one is just test the one right off the bat. Ignore. Because I want to start dumping output here. Oops, I didn't mean to delete it. That's fine. Simple. And it'll be 824, 824, 82. Oh, yeah, okay, this isn't bad. This is only 6 numbers. Okay. I misread it. So we're going to just print out each one as we split it up. So we're going to say println num. And then we're going to see each set of digits. Let mod val is equal to 10 usize pow digit count. Pow digit count, like that. And we're going to say println this num mod val. And this should give us oops, I need a comma. Each set of digits. Oh, yeah. So we don't need that first one. Okay. So here we're going to check for 8 1 1 1 1 1 1 1. It doesn't exist. 2 1 2 1 2 1 2 1, which doesn't exist. 8 2 1 8 2 1 8 2 1, which doesn't exist. Here's where we're going to find the match, right? We're going to find 824 824 824. So, and we can't do shifting, but we can do division. So we can say while let test num is equal to num divided by mod val, while test num is greater than 0, if test num mod val is equal to this value here, let last n digits is equal to this, is equal to the last n digits. If it's not equal to, then it's bad, right? I'm going to say let mod bound is true, bound is false, break. Actually, we could simplify this. We can say found is equal to this. And then if not found, break. And that way we can check found here. If found, invalid sum plus equals num. And I can print found. Like that. We do need to divide test num divided by equals mod val. Okay, let's see if that works. I'm not going to run this from here because I might have an infinite loop here. But I don't think I do, but we'll find out. So cargo test. Yeah, it's finding all of them. Okay, why? Oh, because found is equal to this. The only one it didn't find was the correct one. So it's the test is backwards. There we go. Okay, so that works. So we should now be able to just run it. Say cargo run. Oops. I guess we shouldn't because I'm printing all these things out and I don't need to. Cargo run. I'm still printing them out. All right. Oh, I'm printing them out here. Okay. Why is that smaller? It should be bigger because we're finding more of them. All right. So what range is bad? Let's test a few more ranges here. Let's call this 1. Let's grab this as a test. Let's put a few of them in here. Let's change this to 2. This would be 11 and 22, which should be 33. Let's do another test here. This one should still have only 1. This one should have 1 with repeated 2. So let's make sure that one is working. Right. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Should be 1, 2, 3, 4, 5, 6. And then we have a 5, 6, 5, 6. Let's try that one. 5, 6, 5, 6, 5, 3. And 5, 6, 5, 6, 5, 9. Should be 5, 6, 5, 6, 5, 6. And let's see which one is failing. There we go. Okay, 2 and 3 are failing. Huh. Okay. Time for some more output. Println. I guess I should have just commented it out last time. Num, colon. And then println found. What are we going to call this? Last n digits. There. So, bacon test. So it's not finding 11 or 22. It's not. It found 2, found 22. So actually, it should have found it here. Oh, but it found it here. So once we find it, we need to break out of this loop. Okay, that fixes that bug. But it's not finding 11 or 22. Why not? Oh. Oh, because half digits, I bet you, is 1. It is. So I need to do that? Yeah, gotcha. Okay, so let's get rid of that, get rid of that, get rid of that. And that explains why we're missing some of them, because we were only going part way. Oh, I meant to do cargo run. Yeah, there we go. Oh, the answer is too high. Okay, and I think I'm getting the edge cases because we're seeing the 11 and the 22 here. They're both, it's 33. What could be wrong in my range calculation? Oh, I see what it is. No, I mean, it has to be equal to this. I mean, I was thinking what the problem is that we are, um, I'm filtering out this, right? And I shouldn't be. So let's see. I think it might be this as the invalid range. Let's try it. 95 to 115 should now sum to 99 and 111, which is, can't do it in my head. 9 and 1 is 10 and 1 is 11. So 210? I could just do it here. 99 plus 11. Oh, 111. Why do I have to do it in my head? Test. Okay, that works. Let's try one more. I got to figure out which one it is. Oh, let's change this 5 to a 6. Let's try this range. 998 to 1012, and this should be 999 plus 1010. Now, it's weird that the formatting doesn't work right, but bacon test. Yeah. So all the tests work. What I was thinking was that if you have a 3-digit one, and you're dividing a double, but then this wouldn't work. This wouldn't succeed. Am I missing something else here? So what I did here was, I didn't even check to see if it was even. I just do the calculation. If it's odd, then the upper half won't equal the lower half. My answer is too high. Let me grab this number as being too high before I make any more changes. And make sure that our next, whatever we come up with next, has the right number of answers. Yeah. Okay. So I'm still coming up with that. I got to come up with a test where this fails. Let's take a look at the input. Maybe there's something in the input we can try to figure out what might be going on. Make an assert out of it, so your next solution must be lower. Okay. Sure. How's that? And now if I hit run, it asserts. Okay. Right. What I'm thinking is that it's going to be on an odd one. I guess what I could just do is print them all out and see if there's anything that jumps out at me. Right. Cargo run greater than. Aha. This one jumps out at me. Right? Because this is 7, 7, and then because there's no leading 0. And in fact, he said that. Okay. So we need to somehow figure that out. We have to make sure that there's no leading zeros. Okay, so we can do that pretty easily. We could say if test num I log 10 plus 1 is not equal to digit count. Continue. And that didn't assert. And now we don't have 070707. If I get rid of this print statement now, we do get a number that's wrong because it's the same answer as part 1. Let's print this out. Println test num is less than digit count. I think I'm getting close. Yes, it must be between my upper limit and you're right. Why are we going? Why is my test num? Oh, not our test num. We care about our mod val. That's what I care about. Oh, I got to rerun it. Ten is less than 1. That's true. Oh, no. 10 is not. Oh, we care about the last n digits. That's it. There we go. Let's try this. The argument of integer logarithm must be positive. Oh, it can't be 0. If last n digits is equal to 0, or 0 is less than 1. We don't need zeros. 70 is less than 2. No, that's not true. We got. So I was right to have the +1 in there before, because yeah, okay. Nope. Yeah, okay. So now it's working, right? Because it's saying, oh, this we need to skip. If I go to the end, this number is smaller because we have the assert. So maybe this is the answer? Hey, that's the right answer. Okay, so that was the bug, guys. I had leading 0 digits. Huzzah. And Tommy, I'll take a look in a second. I just want to clean this up. Do I have any other print statements in here? Cargo run. I do not. Cargo clippy. Bacon. I want to run the bacon clippy because it does clippy all. Okay, so this is good. I don't need the assert anymore. I don't need that anymore. And I think we're good. So what I should have done actually was had a test case in here.